Spring Batch architecture. Here you can see a simplified version of the batch reference architecture. Spring Batch is an open source framework for batch processing. It is a lightweight, comprehensive solution designed to enable the development of robust batch applications, which are often found in modern enterprise systems. Spring Batch builds upon the Pocho-based development approach of the Spring framework. Here you can see Spring Batch layered architecture. Here, Spring Batch is designed with extensibility and a diverse group of end users in mind. The following image shows the layered architecture that supports the extensibility and easy of use for end user developments. This layered architecture highlights three major high-level components: application, core, and infrastructure. The application contains all batch jobs and custom code written by developers using Spring Batch. Batch core contains the core runtime classes necessary to launch and control a batch job. It includes implementation for JobLauncher, job, and step. Both application and core are built on top of a common infrastructure. This infrastructure contains common readers and writers and services such as retry template, which are used both by application developers, readers and writers such as ItemReader and ItemWriter, and the core framework itself, retry, which is its own library. Here you can see application interacts with batch core. Batch core interacts with batch infrastructure. Batch infrastructure interacts with the application. Here you can see a partitioned process. Using partitioning lets multiple versions of large batch application runs concurrently. Purpose of this is to reduce the elapsed time required to process long batch jobs. Processes can be successfully partitioned. Those where input file can be split, or the main database tables partitioned to let the application run against different sets of data. In addition, processes that are partitioned must be designed to process only their assigned data set. A partitioning architecture has to be closely tied to the database design and database partitioning strategy. Note that the database partitioning does not necessarily mean physical partitioning of the database, although in most cases this is advisable. Following image illustrates the partitioning approach. The architecture should be flexible enough to allow dynamic configuration of the number of partitions. You should consider both automatic and automatic and user control configuration. Automatic configuration may be based on such parameters as inputs size and number of inputs records. There are partitioning approaches: fixed and even breakups of record set, breakup by a key column, breakup by views, addition of processor indicator, extract table to a flat file, use of hashing column. Here you can see a input is connected to large process is connected to output. Here you can see input is connected to split processors. Split processors are connected to partition processors, or controllers. Here controllers are connected to merge processors, and here merge processors are connected to output. Here you can see a sketch of layered architecture that supports extensibility and easy of use for end user developers. This diagram depicts basically version 2.2.x of Spring Batch. Spring Batch is designed with extensibility and a diverse group of end users in mind. The figure below here shows a sketch of layered architecture that supports the extensibility and ease of use for end user developers. The Spring Batch provides an infrastructure layer in the form of low level tools. There is also a simple execution environments using the infrastructure in its implements. Execution environments provides robust features for traceability and management of the batch lifecycle. A key goal is that the management of a batch process, locating a job and its input, starting, scheduling, restarting, and finally processing to created results, should be as easy as possible for developers. The infrastructure provides the ability to batch operations together and to retry a piece of work if there is an exception. Both requirements have a transactional flavor, and similar concepts are relevant: propagation, synchronization. They also both lend themselves to the template programming model common in Spring. Compare transaction template, JDBC template, JMS template. Here you can see application, same business logic. Application is connected to specialized execution environments. Inside it you can there are SCDA, ESB partition, simple, grid, and JMS. Specialized execution environments are connected to infrastructure, common infrastructure. Application is connected to infrastructure. Here you can see runtime dependence. The runtime dependencies of infrastructure and core with related to Spring Batch 2.2.x. The infrastructure provides the ability to batch operations together and to retry a piece of work if there's an exception. Both requirements have a transactional flavor, and similar concepts are relevant: propagation, synchronization. They also both lend themselves to the template programming model common in Spring. Compare transaction template, JDBC template, JMS template. Core module is the batch focused domain and implementation. It provides a robust set of integrated features including batch processing statistics, JobLauncher, and restart to enable the management of the full life cycle of traditional batch processing. a number of simple sample jobs are packaged in a separate samples module to more clearly articulate the usage of and capabilities of the core module. The runtime dependencies of infrastructure and core are shown in this figure. Here you can see samples, application and core are inside samples. Here you can see Spring Batch, core and infrastructure are in Spring Batch. Here you can see Spring Core, Spring Framework is in Spring Core. Application compiles core, application configure infrastructure, application configure core, and application compile infrastructure here, and core compile infrastructure, core compile core compile Spring Framework, infrastructure compile Spring Framework. Here you can see the interactions and key services provided by the Spring Batch framework. Here, this diagram highlights the interactions and key services provided by the Spring framework. The colors used are important to understand responsibilities for a developer in Spring Batch. Gray represent an external application such as enterprise scheduler or a database. It is important to note that the scheduling is gray and should thus be considered separate from the Spring Batch. Blue represents application architecture services. In most cases, these are provided by Spring Batch with out-of-box implementation, but an architecture team may make specific implementation that better address their specific needs. Yellow represent the pieces that must be configured by the developer. For example, a job schedule needs to be configured so that the job is kicked off at the appropriate time. A job configuration file also needs to be created, which define how a job will be run. It is also worth noting that ItemReader and ItemWriter used by an application may just as easily be a custom made by a developer for their specific batch job rather than providing Spring Batch or architecture team, rather than one provided by Spring Batch or an architecture team. Batch application style is organized into 4 logical tiers, which include run, job, application, and data. The primary goal for organizing an application according to tiers is to embed what is known as separation of concerns within the system. These tiers can be conceptual but may prove effective in mapping deployment of the artifacts into physical components like Java runtimes and integration with data sources and targets. Effective separation of concerns results in reducing impact of change to the system. 4 conceptual tiers containing batch artifacts are run tier. Run tier is concerned with the scheduling and launching of the application. A vendor product is typically used in this tier to allow time-based and independent scheduling of batch jobs as well as providing parallel processing capabilities. Job tier. Job tier is responsible for overall execution of a batch job. It sequentially execute batch steps, ensuring that all steps are in a correct state and all appropriate policies are enforced. Application tier. Application tier contains components required to execute a program. It contains specific tasks that address required batch processing functionality and enforces policies around execution, commit intervals, capture of statistics, etc. Data tier. Data tier provides integration with the physical data sources that might include databases, files, and queues. Here you can see batch application style interactions and services. Here you can see run tier, scheduler, job script, request, job runner, job locator, job configuration, and job configuration are in run tier. Here you can see a job tier, job launcher, job, and job repository are in job tier. Here you can see application tier, steps, item runner, business logic, item writer, data access, and job repository are in application tier. Here you can see data tier, message queue, database, data files, and print queue are in data tier. Here scheduler in run tier, you can see scheduler config is inside scheduler, and scheduler is connected to job script. Job script and request HTTP WS are connected to job tier. Job runner. Job runner is connected to job locator. Job locator is connected to job configuration, app context, and job runner is connected to job launcher. Now we are in job tier. Job launcher is connected to job launcher, and job is connected to job repository. Job is connected to step in application tier. Now we are in application tier. Step is connected to job repository, and step is connected to ItemWriter and ItemReader and ItemWriter 2. Read is passed from step to ItemReader. Write is passed from step to ItemWriter. ItemReader and ItemWriter is connected to business logic. ItemReader is connected to ItemReader, and ItemWriter are connected to data access. Config is inside data access. Data access interacts with data tier, and ItemReader and ItemWriter is are connected to data tier. Message queue, database, data files, and print queues are inside data tier. Here you can see custom application artifacts. Custom application artifacts are here config in scheduler, job scripts, job configuration, app context, business logic, config in data access, and config in data access. Application architecture services. Application architecture services are job runner, job locator, job launcher, job step, job repository, item reader, ItemWriter, and data access. Application web app and VMs are scheduler, request, and here in data tier, message queue, databases, data files, and print queues. Here you can see the overall process flow. Here you can see primary components of Spring Batch and overall process flow in chunk model. Here primary components of Spring Batch and overall process flow is explaining. I'm explaining now. Further explanation is also given about how to manage metadata of execution status of jobs. So primary components of Spring Batch and overall process chunk model are shown in this figure. Here the main processing flow, the black line, and the flow which persists job information, red line, are explained. Main process flow, JobLauncher is initiated from the job scheduler. Step 1. Step 2, job is executed from JobLauncher. Step 3, step is executed from job. Step 4, step fetches input data by using ItemReader. Step 5, step processes input data by using ItemProcessor. Step 6, step outputs process data by using ItemWriter. Now a flow processing, or the flow for persisting job information. JobLauncher registers job instance in database through JobRepository. Step 2 here, JobLauncher registers that job's execution has started in database through JobRepository. Step 3, job step updates miscellaneous information like counts of IO records and status in database through jobs repository. Step 4 here, JobLauncher registers that the job's execution has completed in database through jobs repository. Components and jobs repository focusing on persistence are explained freshly again. The components related to persistence, job instance, job instance. Spring Batch indicates logical execution of a job. Job instance is identified by a job name and arguments in arguments. In other words, execution with identical job name and argument is identified as execution of identical job instance, and job is executed as a continuation from previous activation. when the target job supports re-execution and the process was suspended in between due to an error in previous execution, the job is executed from the middle of the process. In other hand, when the target job does not support re-execution, or when the target job instance has already been successfully processed, exception is thrown and Java process is terminated abnormally. For example, job instance already complete exception is thrown when the process has already been completed successfully. Job execution and execution context. Job execution indicates physical execution of a job. Unlike job instance, it is termed as another job execution even while executing identical job. As a result, job instance and job execution shows one-to-many relationship. Execution context is considered as an area for sharing metadata such as progress of a process, progress of a process in identical jobs execution. Execution context is primarily used for enabling Spring Batch to record framework status. However, means to access execution context by the application is also provided. The object stored in job execution context must be a class which implements java.io.serializable. You can see job execution. Step execution and execution context. Step execution indicates physical execution of step. Job execution and step execution shows one-to-many relationship. Similar to job execution, execution context is an area for sharing data in step. From the viewpoint of localization of data, information which is not required to be shared by multiple steps should use execution context of target step instead of using execution context of job. The object stored in step execution context must be a class which implements java.io.serializable. Job repository, a function to manage and persist data for managing execution result and data for managing execution results and status of batch application like job execution or step execution is provided. In general batch applications, the process is started by starting a Java process, and Java process is also terminated along with the termination process. Hence, since the data is likely to be referred across Java process, it is stored in volatile memory as well as permanent layers like database. Database objects like table or sequence are required for storing jobs execution or job step execution. It is necessary to generate database object based on schema information provided by Spring Batch. Spring Batch heavily manages metadata in order to perform re-execution. A snapshot at the time of earlier execution must be retained, and metadata and job repository should be used as a base in order to re-execute a batch process. Here you can see a Java process and job scheduler. Here the flow of here we are focusing on flow of central processing. Job scheduler is connected to JobLauncher, and run is passed from job scheduler to JobLauncher. And inside the Java process you can see JobLauncher, JobRepository, and job execution. Here JobLauncher is connected to job scheduler is connected to JobLauncher, and JobLauncher is connected to job. Execute is passed from JobLauncher to job, and inside jobs execution, job you can see job and execution context and step executions are there. Job is connected to steps. Execute is passed from job to step. Step execution context, ItemReader, ItemProcessor, ItemWriter and ItemWriter in step execution. There are one or more step executions are inside a job execution. Step execution is connected to ItemReader, ItemProcessor and ItemWriter. Read is passed from step execution to ItemReader. Process is passed from read is passed from step to ItemReader. Process is passed from step to ItemProcessor. Write is passed from step to ItemWriter. With related to flow of job information persistence, JobLauncher, job and steps are connected to JobRepository. CPU operation is passed from step to JobRepository. JobRepository interacts with the database. Now we are focusing on JobLauncher. JobLauncher represents a simple interface for launching a job with a given set of job parameters. Here you can see a JobLauncher sequence. When you use @enable batch processing, a job registry is provided for you. The most basic implementation of JobLauncher interface is the task executor JobLauncher. Its only required dependency is JobRepository needed to obtain an execution. Once jobs execution is obtained, it is passed to the execute method of the job. Ultimately returning jobs execution to the caller, as this as following image shows. This sequence is straightforward and works well when launched from a scheduler. Here you can see a client, JobLauncher, job and business. Run is passed from client to JobLauncher. execute method is passed from job launcher to job, and job interacts with business, and exit status is passed from job to job launcher. The job execution with the status finished or failed is passed from job launcher to client. Here client interacts with job launcher, and job launcher interacts with job interacts with business. Here you can see a synchronous job launcher sequence. However, issues arise when trying to launch from HTTP request. In this scenario, the launching needs to be done asynchronously, so that the task executor job launcher returns immediately to its caller. This is because it is not good practice to keep an HTTP request open for the amount of time needed by long-running process such as batch jobs. The following image shows an example sequence. You can configure a task executor job launcher to allow this scenario by configuring task executor. Here you can see a client interacts with job launcher. Run is passed from client to job launcher, and job execution is passed. Job execution start with exit status dot unknown is passed from job launcher to client, and here you can see job launcher interacts with job, and job interacts with business, and execute is passed from job launcher to job, and job interacts with the business, and exit status is passed from job to job launcher. Here you can see a asynchronous job launcher sequence from web container. Historically, offline processing such as batch jobs has been launched from command line, and however, there are many cases where launching from an HTTP request is better option. Many such use cases include reporting, ad hoc job running, and web application support. Because of a batch job by definition is a long running, most important concern is to launch job asynchronously. Controller in this case is a Spring MVC controller. The controller launches a job by using job launcher that has been configured to launch asynchronously, which immediately return job's execution. The job is likely still running. However, this non-blocking behavior lets the controller return immediately, which is required when handling a HTTP request. Here you can see a controller interacts with job launcher interacts with job. Here the run method is passed from run is passed from controller to job launcher, then execute is passed from job launcher to job, and job execution is passed from job launcher to controller, and and job launcher interacts with job. As an example, we can consider interface JobLauncher, simple interface for controlling jobs, including possible ad hoc executions based on different runtime identifiers. It is extremely important to note that this interface makes absolutely no guarantees about whether or not calls to it are executed synchronously or asynchronously. The Java docs for specific implementation should be checked to ensure callers fully understand how the job will be run. This is in the package org.springframework.batch.core.launch. As an example too, we can consider this. Now we are considering configuring a JobLauncher. Following example shows how task executor JobLauncher in Java. The class task executor JobLauncher implementation of the JobLauncher interface based on a task executor. This means that the type of executor set is very important. If sync task executor is used, then the job will be processed within the same thread that called the launcher. Care should be taken to ensure any users of this class understand fully whether or not the implementation of task executor used will start task synchronously or asynchronously. The default setting uses a synchronous task executor. There is only one required dependency of this launcher, a job repository. The job repository is used to obtain the valid jobs execution. The repository must be used because the provided job could be a restart of an existing job instance, and only the repository can reliably recreate it. This is in the package org.springframework.batch.core.launch.support. When you use @enable batch processing, a job registry is provided for you. This section describes how to configure your own. The most basic implementation of JobLauncher interface is the task executor JobLauncher. Its only required dependency is a job repository needed to obtain an execution. Following example shows task executor JobLauncher in XML, and following example shows a task executor job launcher in Java. Once a job execution is obtained, it is passed to the execute method of job, ultimately returning job's execution to the caller. As an exception example, we can consider job execution already running exception. If the job instance identified by the properties already has an execution running in method job execution run job parameters in interface JobLauncher in the package org.springframework.batch.core.launch. As an error example, we can Consider this application failed to start description. The bean JobLauncher defined in the class path resource could not be registered. A bean with that name has already been defined in the class path and overriding is disabled. Action: consider renaming one of the beans or enabling overriding by setting spring.main.allow bean definition overriding equals true. Now we are focusing on job. A job is an entity that encapsulates an entire batch process. As is common with other Spring projects, a job is wired together with either an XML configuration file or Java-based configuration. This configuration may be referred to as the job configuration. However, job is only the top of an overall hierarchy. Here you can see a process flow from starting a Java process till starting a batch process. How to run a job is explained here. A scenario is considered wherein a batch process is started immediately after starting Java process, and Java process is terminated after completing a batch process. The figure here shows a process flow from starting a Java process till starting a batch process. Starting a Java process and starting a job. A shell script to start Java is generally described to start a job defined on Spring Batch. Along with starting a Java process, when command line job runner offered by Spring Batch is used, job on Spring Batch defined by the user can be easily started. Start command when a bean is defined by using XML, for example a Java -cp, then $class path, or go to Spring framework.bash.core.launch.support.command line job runner, then job path, job name, job argument equal value 1, job argument 2 equal value 2, etc. Specifying a job parameter, command line job runner can pass arguments, job parameters as well along with job name to be started. Arguments are specified in job argument name equal value format as per the example described here. All arguments are stored in job execution after conversion to job parameters after interpreting and checking by command line job runner or job launcher. Register and restore job instance. Job launcher fetches job name from the job repository and job instance matching with the argument from database. When corresponding job instance does not exist, job instance is registered as new. When corresponding job instance exists, associated job execution is restored in Spring Batch for these jobs that can be executed repeatedly, like daily execution, etc. A method to add argument for making the job instance unique is listed. For example, adding system date and or random number to argument are listed. Here you can see a shell script. This is Java example job P1 equal ABC, P2 equal 1, 2, 3. Here you can see Java process, command line runner, interface JobLauncher, repository and job execution are inside Java process. Shell script is connected to command line job runner. Command line job runner is connected to job interface JobLauncher. Run is passed from command line job runner to interface JobLauncher. Interface JobLauncher is connected to JobRepository. Retrieve the final job execution is passed from JobLauncher to JobRepository. The JobRepository interact with database. Here you can see job instance ID 1, job name example job, job key CBEF 882370, etc. Here you can see job instance is connected to job executions. Here you can see job execution ID 1, job instance ID 1, and here job execution ID 2, job instance ID 1. Job execution is connected to job execution paras, job execution ID 1, key P1 and string value ABC. Here job execution paras, job execution ID 1, key P2 and long value 1, 2, 3. JobLauncher is connected to interface JobLauncher is connected to interface job, and interface job, simple job here, execution context and job parameters are inside job execution, and execute is passed from interface JobLauncher to interface job. The interface job is connected to omitted, and simple job implements interface job, name equal example job. Here JobLauncher is connected to job execution. Create is passed from job interface JobLauncher to job execution, and here interface JobLauncher is connected to execution context. Register is passed from the interface JobLauncher to execution context. Here interface JobLauncher is connected to job parameter P1 equal ABC, P2 equal 1, 2, 3. Register is passed from interface JobLauncher to job parameter. Here you can see a job hierarchy. Here we describe stereotypes relating to the concept of batch job. Here we are constantly focusing on job. A job is an entity that encapsulates entire batch process. As is common with other Spring projects, a job is wired together with either an XML configuration file or Java-based configuration. This configuration may be referred to as the job configuration. However, job is only the top of an overall hierarchy as shown in this diagram. In Spring Batch, a job is simply a container for step instances. It combines multiple steps that logically belong together in a flow and allows for configuration of properties global to steps such as restartability. The job configuration contains name of the job, definition and ordering of the step instances, whether or not the job is restartable. A job instance refers to the concept of a logical job run. Consider a batch job that should be run once at the end of the day. End of the day job from this diagram. There is one end of day job, but each individual run of the job must be tracked separately. In the case of this job, there is one logical job instance per day. For example, there is a January 1st run, January 2nd run, and so on. If the January 1st run fails the first time and is run again in the next day, and it is still the January 1st run, usually this corresponds with the data it is processing as well, meaning the January 1st run processes data for January 1st. Therefore, each job instance have multiple executions, and only one job instance which correspond to the particular job and identifying job parameters can run at a given time. The definition of a job instance has absolutely no bearing on the data to be loaded. It is entirely up to the ItemReader implementation to determine how data is loaded. For example, on the end of day scenario, there may be a column on the data that indicates the effective date or schedule date to which the data belongs. So the January 1st run would load only data from the first, and January 2nd run would use only data from the second. Because of this determination is likely to be business decision, it is left up to the ItemReader to decide. However, using the same job instance determines whether or not the state from previous execution is used. Using a new job instance means starting from the beginning, and using an existing instance generally means start from where you left off. Job execution. A job execution refers to the technical concept of a single attempt to run a job. An execution may end in a failure or success. But the job instance corresponding to a given execution is not considered to be complete unless the execution completes successfully. Using end of day job described here, consider a job instance for 1st of January 2017 that failed first time it was run, and if it is run again with the same identifying job parameters as the first run, 1st of January 2017, a new job execution is created. However, there is still only one job instance. A job defines what a job is and how it is to be executed, and job instance is a purely organizational object to group executions together, primarily to enable correct restart semantics. A job execution, however, is the primary storage mechanism for what actually happened during a run and contain many more properties that must be controlled and persisted. here the job, you can see the job, the end of J job. Job is connected to multiple job instances. Here the end of day job for 2007 05. Here the job instance is connected to multiple job execution. The first attempt at end of day job for 2007 05. Now here you can see job parameters. Having discussed the job instance and how it differs from job, a natural question mark is how is one job instance distinguished from another? The answer is job parameters. A job parameters object holds a set of parameters used to start a batch job. They can be used for identification or even as a reference data during the run, as following image shows. In this example, where there is two instances, one for January 1st and another for January 2nd, and there is really only one job, but it has two parameter objects. One that was started with job parameter of 01-01-2017, and another that was started with parameter of 01-02-2017. Thus the contract can be defined as job instance equal job plus identifying job parameters. This allows the developer to effectively control how a job instance is defined, since they control what parameters are passed in. Note, not all job parameters are required to contribute to the identification of job instance. By default, they do so. However, the framework also allows the submission of a job with parameters that do not contribute to identify contribute to the identity of a job instance. Here you can see a job end of the end of day job. Job is connected to multiple job instances. Job, here you can see job parameters, schedule date equal 2007-05. Job parameters are connected to job instance. Here end of day job for 2007-05. Here job instance is connected to multiple job executions, many job executions. Here the first attempt at end of the job for 2007-05. Here you can see launch a batch job. Here we are considering launching batch jobs through messages. When starting batch jobs by using the core Spring Batch API, you basically have two options. From the command line with command line job runner, second option programmatically with either JobOperator.start method or JobLauncher.run method. For example, you may want to use command line job runner when invoking batch jobs by using a shell script. Alternatively, you can use job operator directly. For example, when using Spring Batch as a part of a web application. However, what about more complex use cases? Maybe you need to call a remote FTP server to retrieve the data for batch job, or your application has to support multiple different data sources simultaneously. For example, you may receive data files not only from the web but also from FTP and other sources. Maybe additional transformation of the input files is needed before invoking Spring Batch. Therefore, it would be much more powerful to execute the batch job by using Spring integration and its numerous adapters. For example, you can use file inbound channel adapter to monitor a directory in the file system and start the batch job as soon as the input file arrives. Additionally, you can create Spring integration flows that use multiple different adapters to easily ingest data for your batch jobs from multiple sources simultaneously by using only configuration. Implementing all these scenarios with Spring integration is easy, as it allows to decouple the event-driven execution of JobLauncher. Spring Batch integration provide JobLauncher message handler class that you can use to launch batch jobs. The input for JobLauncher message handler is provided by Spring integration message, which has a payload of JobLauncher request. This class is a wrapper around the job to be launched and around job parameters that are necessary to launch the batch job. Following image shows the typical Spring integration message flow that is needed to start a batch job. The EIP Enterprise Integration Patterns website provides a full overview of messaging icons and their descriptions here. Here you can see FTP is connected to an inbound channel adapter. Inbound channel adapter is connected to transformer, and here you can see file and JobLauncher request here, and then it's connected to JobLauncher. As an example, we can consider interface job batch domain object representing a job. Job is an explicit abstraction representing the configuration of a job specified by a developer. Note that the restart policy is applied to the job as a whole and not to a step. Package this is in the package org.springframework.batch.core. Now we are focusing on restartability. The following example shows how to set the restartable field to false in Java. Here the method public b prevent restart set the flags to prevent restart and execution of this job even if it has failed. This is in the class job builder helper b extend job builder helper b, and in the package org.springframework.batch.core job.builder. One key issue when executing a batch job concerns the behavior of a job when it is restarted. Launching a job is considered to be a restart if a job execution already exits for a particular job instance. Ideally, all jobs should be able to start up where they left off, but there are scenarios where this is not possible. In this scenario, it is entirely up to the developer to ensure that a new job instance is created. However, Spring Batch does not provide some help. If a job should never be restarted but should always be run as part of new job instance, you can set the restartable property to false. The following example shows how to set restartable field to false in XML. The following example shows how to set restartable field to false in Java. To place it another way, setting restartable to false means this job does not support being started again. Restarting a job that is not restartable causes a restartable exception to be thrown. Here now we are considering Java configuration. The following example shows how to provide a custom data source and a transaction manager. Annotation interface enabled batch processing, enable Spring Batch features and provide base configuration for setting up batch jobs in an at configuration class were roughly equivalent to using the batch XML namespace. Spring 3 brought the ability to configure application with Java. Instead of XML. As of Spring Batch 2.2.0, you can configure batch jobs by using the same Java configuration. There are 3 components for Java-based configuration: enable batch processing annotation and 2 builders. The enable batch processing annotation works similarly to the other enable annotations in the Spring family. In this case, enable batch processing provides a base configuration for building batch jobs. Within this base configuration, an instance of step scope and job scope are created. In addition to a number of beans being made available to be auto-wired, JobRepository, a bean named JobRepository, JobLauncher, a bean named JobLauncher, JobRegistry, a bean named JobRegistry, JobExplorer, a bean named JobExplorer, JobOperator, a bean named JobOperator. The default implementation provides the beans mentioned in the preceding list and requires a data source and a platform transaction manager to be provided as beans within the context. The data source and transaction manager are used by JobRepository and JobExplorer instances. By default, the data source named data source and a transaction manager named transaction manager will be used. You can customize any of these beans by using attributes of the enable batch processing annotation. The following example shows how to provide custom data source and transaction manager. Not only one configuration class needs to have the enable batch processing annotation. Once you have a class annotated with it, you have all the configuration described earlier. Define job flow as needed. This class provides the same beans provided by @enable batch processing and can be used as a base class to configure batch jobs. Following snippet is a typical example of how to use it. The class default batch configuration, base configuration class that provides common JDBC based infrastructure beans for enabling and using Spring Batch. This configuration class configures and registers the following beans in the application context: a job repository named JobRepository, a job explorer named JobExplorer, a job launcher named JobLauncher, a job registry named JobRegistry, a step scope named StepScope, a job scope named JobScope. This is in the package org.springframework.batch.core.configuration.support. The starting from version 5.0, an alternative programmatic way of configuring base infrastructure beans is provided through the default batch configuration class. This class provides the same beans provided by @enable batch processing and can be used as a base class to configure batch jobs. Following snippet is a typical example of how to use it. The data source and transaction manager will be resolved from the application context and set on the job repository and job explorer. Define job flow as needed. Here we are considering running a job in the command line job runner in running jobs from command line. The following example shows a date passed as a job parameter to a job defined in Java. The class command line job runner, basic launcher for starting jobs from the command line. In general, it is assumed that this launcher will primarily be used to start a job via a script from an enterprise scheduler. Therefore, exit codes are mapped to integers so that schedulers can use the return values to determine the next course of action. The return values can also be used to operations teams in determining what should happen upon failure. For example, a return value code of 5 might mean that some resource wasn't available and the job should be restarted. However, the code of 10 might mean that something critical has happened and this issue should be escalated. This is in the package org.springframework.batch.core.launch.support. Because the script launching the job must kick off a Java virtual machine, there needs to be a class with a main method to act as a primary entry point. The Spring Batch provides an implementation that serves this purpose: command line job runner. Note that this is just one way to bootstrap your application. There are many ways to launch a Java process, and this class should in no way be viewed as a definitive. The command line job runner performs 4 tasks: load the appropriate application context, pass command line arguments into job parameters, locate appropriate job based on argument, use the job launcher provided in the application context to launch the job. All of these tasks are accomplished with only the arguments passed in the job path, the location of the XML file that is used to create an application context. This file should contain everything needed to run the complete job. Job name, the name of the job to be run. These arguments must be passed in with the path first and the name second. All arguments after this are considered to be job parameters, are turned into a job parameters object and must be in the format of name equal value. The following example shows a date passed as a job parameter to a job defined in XML. Following example shows a date passed as a job parameter to a job defined in Java. By default, command line job runner uses a default job parameter converter that implicitly convert key value pairs to identify job parameters. However, you can explicitly specify a job parameters are identifying and which are not by suffixing them with true or false respectively. Now we are considering running jobs from within a web container. However, this non-blocking behavior lets the controller return immediately, which is required when handling an HTTP request. The following listing shows an example. Historically, offline processing such as batch jobs has been launched from the command line as command line. However, there are many cases where launching from an HTTP request is a better option. Many such cases include reporting, ad hoc job running, and web application support. Because batch job by definition is long running, the most important concern is to launch the job asynchronously. The controller in this case is a Spring MVC controller. See the Spring Framework reference guide for more information about Spring MVC. The controller launches a job using JobLauncher. That has been configured to launch asynchronously, which immediately returns job's execution. The job is likely still running. However, this non-blocking behavior lets the controller return immediately, which is required when handling an HTTP request. The following listing shows an example. Um, Now we are considering querying the job repository in advanced metadata usage. Following example shows how to configure Job Explorer in Java. The interface Job Explorer, entry point for browsing the execution of running or historical jobs and steps. Since the data may be rehydrated from persistent storage, it cannot contain volatile fields that would have been present when the execution was active. This is in the package org.springframework.batch.core.explorer. The most basic need before any advanced features is the ability to query the repository for existing executions. This functionality is provided by Job Explorer interface. As is evident from its method signatures, Job Explorer is a read-only version of the job repository, and like the job repository, it can be easily configured by using factory bean. Following example shows how to configure Job Explorer in XML. Following example shows how to configure Job Explorer in XML. And following example shows how to configure Job Explorer in Java. This would reside in your batch configurer implementation. Now we are considering a separate example. Here we have put together a batch job. To configure your job, you must first create a Spring at configuration class like the following example in source main java com example batch processing batch configuration.java. The annotation interface enable batch processing, enable Spring batch features, and provide the base configuration for setting up batch jobs in at configuration class, roughly equivalent to using the batch XML namespace. This is in the package org.springframework.batch.core.configuration.annotation. Now you need to put together the actual batch job. Spring Batch provides many utility classes that reduce the need to write custom code. Instead, you can focus on business logic. To configure your job, you must first create a Spring configuration at configuration class like the following example in source main java com example batch processing batch configuration.java. For starters, at enable batch processing, annotation adds many critical beans to support jobs and save you a lot of legwork. This example uses memory-based database provided by @enable batch processing, meaning that when it is done, the data is gone. It also auto-wires a couple, The last chunk from source main Java com example batch processing batch configuration.java shows the actual job configuration. The class job builder factory, convenient factory for a job builder that sets the job repository automatically. This is in the package org.springframework.batch.core.configuration.annotation. The first method here defines the job, and the second one defines the single step. In this job definition, you need an incrementer because jobs use because jobs use a database to maintain execution state. You then list each step, though this job has only one step. The job ends and the Java API produces a perfectly configured job. The last bit of batch configuration is the way to get notified when the job completes. The following example here from source/main/java/com/example/batch processing/job completion notification listener.java shows such a class. The job completion notification listener listened for a job. Listen when a job is batch status dot completed, and then uses JDBC template to inspect the results. As an exception example, we are considering class job execution exception, root of exception hierarchy for checked exception in job and step execution. Clients of the job should expect to have to catch and deal with these exceptions because they signal a user error or an inconsistent state between the user's instructions and the data. This is in the package org.springframework.batch.core. As an error example, we can consider this. Here you can see the flow execution ended unexpectedly and etc. This is org.spring framework.batch.core.job.flow flow job do execute etc. Yeah. Now we are focusing on step. A step is a domain object that encapsulates an independent sequential pace of a batch job. Therefore, every job is composed entirely of one or more steps. A step contains all the information necessary to define and control the actual batch processing. This is a necessarily vague description because the contents of any given step are at the discretion of the developer writing a job. A step can be as simple or complex as the developer desires. A simple step might load data from a file into the database, requiring little or no code depending upon the implementations used. A more complex step may have complicated business rules that are applied as part of the processing. As with the job, a step has an individual step execution that correlates with a unique job execution. Here you can see the process flow from steps to tasklet. The execution of business logic. The job is divided into smaller units called steps in Spring Batch. When a job is started, job activates already registered steps and generates step execution. Step is a framework for dividing the process till the end, and the execution of business logic is delegated to tasklet from step. A couple of methods can be listed as the implementation methods of tasklet: chunk model and tasklet model, which since the overview has already been explained here, the structure will be now explained here. The chunk model here, as described here, as described before, chunk model is a method wherein the processing is performed in a certain number of units, chunks, rather than processing the data to be processed by one unit. Chunk-oriented tasklet act as a concrete class of tasklet which supports the chunk processing. Maximum records of data to be included in the chunk, hereafter referred as chunk size, can be adjusted by using setup value called commit interval of this class. ItemReader, ItemProcessor, and ItemWriter are all the interfaces based on chunk processing. Chunk model is a framework suitable for batch applications that read multiple input data one by one and perform a series of processing. However, a process which does not fit with the type of chunk processing is also implemented. For example, when system command is to be executed and when only one record of table for control is to be updated. In such case, merits of efficiency obtained by chunk processing are very less, and demerit owing to difficult design and implementation are significant. Hence, it is rational to use tasklet model here. It is necessary to use for user to implement tasklet interface provided by Spring Batch using while using the tasklet model. Here you can see job execution, interface job, execution context, job parameter, and step executions are inside the job execution. Execute is connected to interface job. Interface job is connected to interface step. Execute is passed from interface job to interface step. Interface job is connected to job execution. Create is passed from interface job to job execution. Interface job is connected to execution context. Register is passed from interface job to execution context. And here you can see execution context and job parameters. Here job parameter P1 equal ABC, P2 equal 1, 2, 3. Inside the step execution, this is you can see the step execution here. Interface step, tasklet step, interface tasklet processing method, and chunk processing method and execution context are inside step execution. Interface step, here the tasklet step is connected to interface step, and implement is passed from tasklet step to interface step. Tasklet step is connected to interface tasklet. Execute is passed from tasklet step to interface tasklet. Here XXX tasklet is connected to interface tasklet. XXX tasklet is inside tasklet processing method. User implement is passed from XXX tasklet to interface tasklet. Here chunk oriented tasklet is connected to interface tasklet. Implement is passed from chunk oriented tasklet to interface tasklet. Chunk oriented tasklet, ItemReader, interface ItemReader, interface ItemProcessor, interface ItemWriter, and interface ItemWriter are inside chunk processing method. Chunk oriented tasklet is connected to ItemReader. Read is passed from chunk oriented tasklet to interface ItemReader. Chunk oriented task is connected to interface ItemProcessor. Process is passed from chunk oriented tasklet to interface ItemProcessor. Chunk oriented tasklet is connected to interface ItemWriter. Write is passed from chunk oriented tasklet to interface ItemWriter. Here you can see chunk processing by using chunk oriented tasklet. Chunk model is a method wherein the processing is performed in a certain number of units, chunks. Rather than processing data to be processed by one unit, chunk-oriented tasklets act as a concrete class of tasklet which supports the chunk processing. Maximum records of data to be included in the chunk, hereafter referred as chunk size, can be adjusted by using step value called commit interval of this class. ItemReader, ItemProcessor, and ItemWriter are all the interfaces based on chunk processing. The explanation is given about how chunk-oriented tasklet calls ItemReader, ItemProcessor, and ItemWriter. The sequence diagram wherein chunk-oriented tasklet processes one chunk is shown here. Chunk-oriented tasklet repeatedly execute on ItemReader and ItemProcessor by the chunk size. In other words, reading and processing of data. After completing reading all data chunks, data writing process of ItemWriter is called only once, and all the processed data in the chunk is passed. Data update processing is designed to be called once for chunks to enable easy organizing, like at batch and execute batch of JDBC. The ItemReader and ItemProcessor and ItemWriter, which are responsible for actual processing in chunk processing, are introduced. Although it is assumed that the user handles its own implementation for each interface, it can also be covered in generic concrete class provided by Spring Batch. Especially since ItemProcessor describes the business logic itself, the concrete class hardly provided by Spring Batch. This ItemProcessor interface is implemented while describing the business logic. ItemProcessor is designed to allow types of object used in I/O to be specified in respective generics so that type-safe programming is enabled. Here you can see a chunk-oriented tasklet, interface ItemReader, interface ItemProcessor, interface ItemWriter. Here execute is passed to chunk-oriented tasklet, and here you can see frameworks transaction here, and inside it you can see the create chunk items and repeat until chunk size is reached here, and inside it you can see a read and chunk oriented tasklet interacts with interface ItemReader, and read is passed from chunk oriented tasklet to interface ItemReader, and item is passed from interface ItemReader to chunk oriented tasklet. Here process item is passed from chunk oriented tasklet to interface ItemProcessor, and item is passed from interface ItemProcessor to chunk oriented tasklet. These are inside create chunk items and repeat until check size is reached. Then write items is passed from chunk oriented tasklet to interface ItemWriter, and this is in the framework transaction, and finally the repeat status is passed from chunk oriented tasklet. Here you can see Spring Batch job parameters, and we are also focusing on steps here. In enterprise application, batch job usually consists of multiple steps. During each step, we may perform following operations: read input data, process input data, write the process data. Also, if a batch job has multiple steps, then the output of one steps is many times used as input of the next step, so on. One of the features of Spring Batch is that it provides reusable components. These components can be used to process large volumes of data and perform operations like job restart, skip, job processing metadata, logging and tracing, and transaction management. What are job parameters? Job parameters are likely key value pairs that data you provide when you start a job. A job has different job instances, and these job instances differ on the basis of job parameters. Job parameters can be used for identification during the job run. They have reserved names, so to access them, and we can use Spring expression language. For example, we can provide following as a job parameters: file path of the source location containing the files to be processed by a Spring batch. The path of the target location where processed files should be written by Spring batch. Here you can see job and Spring batch job parameters are passed from Spring to Spring batch launcher, and Spring batch launcher is connected to Spring batch job. Create and executes job instance is passed from Spring batch launcher to Spring batch job, and in Spring batch job you can see step 1, step 2, and step 3. Here you can see ItemReader is connected to ItemProcessor, and ItemProcessor is connected to ItemWriter, and step 1 is connected to step 2 here, and step 1 output as input to step 2 is passed from step 1 to step 2, and here step 2 is connected to step 3, and step 2 output as input to step 3 is passed from step 2 to step 3, and here you can see ItemReader, ItemProcessor, and ItemWriter are inside step 1, and again same is inside step 2, and again same is inside step 3. Here you can see a job hierarchy with steps. A step is a domain model that encapsulates an independent sequential pace of batch job. Therefore, every job is composed entirely of one or more steps. A step contains all of the information necessary to define and control the actual batch processing. This is necessarily vague description because the content of any given step are at the discretion of developer writing a job. A step can be as simple or complex as the developer desires. A simple step might load data from a file into database, requiring a little or no code depending upon the implementation used. A more complex step may have complicated business rules that are applied as part of processing. As with job, step has an individual step execution that correlates with the unique job execution, as the following image shows. Step execution represents a single attempt to execute a step. A new step execution is created each time step is run, similar to job execution. However, if a step fails to execute because the step before it fails, no execution is persistent for it. The step execution is created only when its step is actually started. The step executions are represented by object of the step execution class. Each execution contains a reference to its corresponding step and job execution, and transaction related data such as commit and rollback counts and start and end times. Additionally, each step execution contains an execution context, which contains any data a developer needs to have persisted across batch runs, such as statistics or state information needed to restart. Here you can see job is connected to many steps, and step is connected to many step execution, and here job is connected to many job instances, and job instance is connected to many job executions, and job execution is connected to many step executions. Here you can see the step. A step is a domain object that encapsulates an independent sequential phase of a batch job that contains all of the information necessary to define and control the actual batch processing. This is a necessary vague description because the content of any given step are at the discretion of the developer writing a job. A step can be as simple or complex as the developer desires. A simple step might load data from a file into database, requiring little or no code depending upon the implementations used. For more complex step might have complicated business rules that are applied as part of the processing, as following image shows. Here ItemReader is connected to step, and step interacts with ItemProcessor, and step is connected to ItemWriter. Here you can see chunk oriented processing. Spring Batch uses chunk-oriented processing style in its most common implementation. Chunk-oriented processing refers to reading data one at a time and creating chunks that are written out within the transaction boundary. Once the number of items read equal to the commit level, commit interval, the entire chunk is written out by the ItemWriter, and then the transaction is committed. The following image shows the process. The following pseudocode shows the concept in a simplified form. Here you can see step, ItemWriter, and step, ItemReader, and ItemWriter. So execute is passed to step, and read is passed from step to ItemReader, and item is passed from ItemReader to step, and here read is passed from step to ItemReader, and item is passed from ItemReader to step, and here write items is passed from step to ItemWriter, then and exit status is passed from step. Here you can see chunk-oriented processing with ItemProcessor. You can also configure chunk-oriented step with an optional ItemProcessor to process items before passing them to ItemWriter. Following image shows the process when ItemProcessor is registered in the step. Here you can see step, ItemReader, ItemProcessor, and ItemWriter. Execute is passed to step, and read is passed from step to ItemReader, and item is passed from ItemReader to step. Read is passed from step to ItemReader. And item is passed from ItemReader to step. Process is passed from step to ItemProcessor. Process item is passed from step to ItemProcessor. Process the item is passed from ItemProcessor to step. Here process item is passed from step to ItemProcessor, and processed item is passed from ItemProcessor to step. Here the right processed items is passed from step to ItemWriter, and exit status is passed from step. Here you can see a sequential flow. The simplest flow scenario is a job where all steps execute sequentially, as the following image shows. This is achieved by using next in a step. Following example here shows how to use next method in Java. Here in this scenario, step A runs first because it's the first step listed, and if step A complete normally, step B runs and so on. However, if step A fails, the entire job fails, and step B does not execute. With the Spring Batch XML namespace, the first step listed in the configuration is always the first step run by the job. Order of the other step element does not matter, but the first step must always appear in the XML. Here you can see step A is connected to step B, and step B is connected to step C. Here you can see the conditional flow. With sequential flow, there are only two possibilities. The step is successful, and next step should be executed. The step failed, thus the job should fail. In many cases, this may be sufficient. However, what about the scenario in which the failure of a step should trigger a different step rather than causing failure? The following image shows such a flow. To handle more complex scenarios, the Spring Batch XML namespace let you to define transaction elements within a step element. On such transaction is the next element, like next attribute. The next element tells the job which step to execute next. However, unlike the attribute, any number of next elements are allowed in a given step. There is no default behavior in case of failure. This means that if the transaction elements are used, all the behavior for the step transition must be defined explicitly. Not also a single step cannot have both next attribute and transition element. The next element specifies the pattern to match and the steps to execute next. Java API offers a fluent set of methods that lets you specify the flow and what to do when step fails. Following here example shows how to specify the one step A, and then proceed to either of two different steps, step B or step C, depending on whether step A succeeds. When using XML configuration, on attributes of a transition element uses simple pattern matching scheme to match exit status that results from the execution of the step. When using Java configuration, on method uses a simple pattern matching scheme that to match the exit status that results from the execution of the step. Only two special characters are allowed in the pattern, asterisk and question mark. Asterisk matches 0 or more characters, and question marks matches exactly one character. For example, C asterisk T means cat and count, while C question mark T means matches cat but not count. While there is no limit to the number of transition elements on a step, if a step execution result and exit status that is not covered by an element, the framework throws an exception and job fails. The framework automatically orders transition from one specific at least specific. This means that if even if the ordering was swapped for step A in this example, and the exit status failed, would still go to step C. Here you can see a step is connected to success and here if it is yes, let's go to step B, and if it is no, let's go to step C. As an example, we are considering interface step. Batch domain interface representing the configuration of a step. As with the job, a step is meant to explicitly represent the configuration of a step by a developer, but also ability to execute the step. This is in the package org.springframework.batch.core. Here we are considering configuring a step in chunk-oriented processing. When using Java configuration, you can use Spring Batch builder, Spring Batch builders, as following example shows. The class step builder, convenient entry point for building all kinds of steps. Use this as a factory for fluent builders of any steps. This is in the package org.springframework.batch.core.step.builder. Despite relatively short list of required dependencies for a step, it is an extremely complex class that can potentially contain many collaborators. To ease configuration, you can use Spring Batch XML namespace as following example shows. When using Java configuration, you can use Spring Batch builders. as following example shows. Note the job repository is typically auto-wired in and not needed to be explicitly configured. Note that the transaction manager is typically auto-wired and in and not needed to be explicitly configured. Now we are considering a tasklet adapter in tasklet step. Following example shows how to define a tasklet adapter. The class method invoking tasklet adapter, a tasklet that wraps a method in a POJO. By default, the return value is exit status.completed unless the delegate POJO itself returns an exit status. POJO method is usually going to have no arguments, but static argument or array of arguments can be used to setting the arguments property. This is in the package org.springframework.bash.core.step.tasklet. The tasklet adapter, as with other adapters for the ItemReader and ItemWriter interfaces, the tasklet interface contains an implementation that allows for adapting itself to any pre-existing class tasklet adapter. An example where this may be useful is an existing DAO that is used to update a flag on a set of records. You can use tasklet adapter to call this class without having to write an adapter for tasklet interface. Following example shows how to define tasklet adapter. Following example shows how to define tasklet adapter in Java, here in XML. Here you can see an example tasklet implementation. Following example taken from the Spring Batch samples project is a tasklet implementation with just such a responsibility. Interface tasklet. This is a functional interface and can therefore be used as the assignment target for a lambda expression or method reference. So that's the description for how to use a functional interface. Basically, this interface tasklet is a strategy for processing in a step. This is in the package org.springframework.batch.core.step.tasklet. Many batch jobs contain steps that must be done before main processing begins. To set up various resources, so after processing has completed, to clean up these resources. In the case of a job that works heavily with files, it is often necessary to delete certain files locally after they have been uploaded successfully to another location. Following example taken from the Spring Batch samples project is a tasklet implementation with just such a responsibility. This tasklet implementation deletes all files within a given directory. It should be noted that the execute method is called only once. All that left is to reference the tasklet from the step. Following example shows how to here the following example shows how to reference the tasklet from the step in Java. The following example shows how to reference the tasklet from the step in XML. Here we are considering sequential flow in controlling step flow. Following example shows how to use next method in Java. The public simple job builder next step continue or end a job with a step if a previous step is successful. This is in the class simple job builder. In the package org.spring-framework.batch.co.job.builder. The simplest flow scenario is a job where all the steps execute sequentially, as like here, and this can be achieved by using next in steps. The following example shows how to use next attribute in XML, and the following example shows how to use next method in Java. In the scenario here, step A runs first because it is the first step listed. If the step A completes normally, step B runs, and so on. However, if step A fails, the entire step fails and step B does not execute. With the Spring Batch XML namespace, the first step listed in the configuration is always the first step run by the job. Order of the other step elements does not matter, but the first step must always appear in the first in the XML. Here we are considering programmatic flow decisions in controlling step flow. In this case, a job execution decider can be used to assist in the decision, as following example shows. The interface job execution decider interface allowing for programmatic access to the decision on what the status of a flow should be. For example, if some condition that's stored in the database indicates that the job should stop, for a manual check, a decider implementation could check that value to determine status of the flow. This is in the package org.spring-framework.batch.co.job.flow. In some situations, more information than exit status may be required to decide which steps to execute next. In this case, a job execution decider can be used to assist in the decision, as the following example shows. and here you can see step execution also there. In the following sample job configuration, decision specified decider to use as well as all the transitions. In the following example, a bean implementing job execution decider is passed directly to next call when using Java configuration. We are now considering late binding of step attributes. Following example shows how to access execution context in Java. Class execution context, the job object representing a context for an item stream. It is thing wrapper for a map that allows optionally for type safety on reads. It also allows for dirty checking by setting a dirty flag whenever any put is called. Note that putting null value is equivalent to removing the entry for the given key is in the package org.springframework.batch.item. A class step scope. The annotation interface step scope, convenient annotation for a step scope beans. It default to the proxy mode so that it need not be specified explicitly for every bean definition. Use this for any at bean that needs to inject at values from the step execution step context, and for any bean that needs to share the lifecycle of with the step execution, such as item stream. This is in the package org.springframework.batch.core.configuration.annotation. The following example shows how to access execution context in XML. As a separate example, we are considering the put together a batch job. The last chunk from source main Java com example batch processing configuration.java shows the actual job configuration. Here the class step builder factory, convenient factory for a step builder which sets the job repository automatically. This is deprecated for removal. This API element is subject to removal in future version, deprecated as of version 5.0 and scheduled for removal in version 5.2 in favor of using step builder. This is in the package org.springframework.bash.code.configuration.annotation. Here the first method define the job, and second one define a single step. Jobs are built from steps, where each step invoke a reader, a processor, and a writer. You list each step here, and in step definition you define how much data to write at a time. In this case it writes up to 10 records at a time. Next you configure reader, processor, and writer. Chunk is prefixed person because it's a generic method that represents the input and output types of each chunk of processing and lines up with ItemReader person and ItemWriter person. As an exception example, we can consider no such step exception to signal that a step was requested that is unknown or does not exist. This is in the package org.springframework.bash.code.step. As an error example, we are considering ending at a step. Following example shows a scenario in Java. The public static final exit status failed. Convenient is constant value representing finished processing with an error. This is in the class exit status in the package org.springframework.batch.co. Configuring a step and instruct a job to stop with the batch status of completed. A job that has finished with the status of completed cannot be restarted. The framework throws job instance already complete exception. When using XML configuration, you can use the end element of this task. End element for this task. The end element also allows an optional exit code attribute that you can customize the exit status of the job. If no exit code attributes given, the exit status is completed by default to match the batch status. When you using Java configuration, the end method is used for this task. The end method also allows for an optional exit status parameter that you can use to customize exit status on the job. If no exit status value is provided, the exit status is completed by default to match the batch status. Consider the following scenario. If step 2 fails, the job stops with the batch status of completed and an exit status of completed, and step 3 does not run. Otherwise, execution moves to step 3. Note that if the step 2 fails, the job is not restartable because the status is completed. Following example shows the scenario in XML, and following example shows the scenario in Java. As an error example 2, we can consider this error simple async task executor 1 org.springframework.batch.core.step.abstract encountered an error saving batch metadata. This job is now in an unknown state and should be restarted, should not be restarted, etc. Now we are focusing on job repository. Job repository is the persistent mechanism for all of the stereotypes mentioned earlier. It provides CRUD operations for JobLauncher, job and step implementations. When a job is first launched, a job execution is obtained from the repository. Also, during the course of execution, step execution and job execution implementations are persisted by passing them to the repository. Here you can see job repository. Here you can see the job launcher and job repository interfaces. Together they represent the simple launching of a job, basically, and basic CRUD operations of batch domains objects. Job launcher uses the job repository to create new job execution objects to run them. Job and step implementations later use the same job repository for basic updates of the same executions during the running of a job. Basic operations suffice for simple scenarios. Here you can see job launcher run job. Job launch is connected to job repository, CRUD operations here, and job repository is connected to database. Here you can see advanced job repository access. However, in large batch environment with hundreds of batch jobs, complex and complex scheduling requirements, more advanced access to metadata is required. The job explorer and job operator interfaces add additional functionality for querying and controlling the metadata. Here you can see job operator combines all, and job operator is connected to job launcher and job explorer. Here you can see job launcher run job. Job launcher is connected to job repository, CRUD operations here, and job repository is connected to the database. Here job operator is connected to job explorer, get strict operations, and job explorer is connected to database. Spring batch metadata tables. You can see here the Spring batch metadata ERD. Spring batch metadata tables closely match the domain objects that represent them in Java. For example, job instance, jobs execution, job parameters, step execution, map to batch job instance, batch job execution, batch job execution params, and batch step execution respectively. Execution context maps to a batch job execution context and batch step execution context. Batch repository is the job repository is responsible for saving and storing each Java objects into its correct table. When viewing various table creation statements, note that the data types used are as generic as possible. Like here, Spring Batch provide many schemas as examples. All of them have varying data types due to variations in how individual database vendors handle data types. The following image shows an ERD model of all 6 tables and their relationships to one another. Here the batch job instance table. Batch job instance table holds all information relevant to job instance and serves as top level of overall hierarchy. The job instance ID, I'm going to describe each column in the table. Job instance ID, unique ID that identifies the instance. It is also the primary key. The value of the column should be obtainable by calling getID mentioned in job instance, getID method on job instance. Version, job name of the job obtained from the job object. Because it is required to identify the instance, it must not be null. Job key, a serialization of the job parameters that uniquely identify the separate instances of the same job from one another. Job instances with same job name must have different job parameters and thus different job key values. Batch jobs execution params table. Batch job execution params table hold all information relevant to the job parameters object. It contains 0 or more key value pairs passed to a job and serves as a record of the parameters with which a job was run. For each parameter that contributes to the generation of job's identity, the identifying flag is set to true. Note that the table has been denormalized rather than creating a separate table for each type. There is one table with column indicating the type. The following list describes each column. Job execution ID, foreign key from the batch job execution. Here the foreign key from the batch job execution table that indicates the job execution to which the parameter entry belongs. Note that the multiple rows, that is key value pairs, may exist for each execution. Parameter name, parameter type, fully qualified name of the type of the parameter, parameter value, identifying flag indicating whether the parameter contributed to the identity of the related job instance. Note that there is no primary key for this table. This is because the framework has no use for one and thus does not require it. If need be, you can add a primary key with the database generated key without causing any issues to the framework itself. Batch job execution table. The batch job execution table holds all the information relevant to the job execution object. Every time job is run, there is always a new called job execution and a new row in this table. Following, let's describe the each column. Jobs execution ID, primary key that uniquely identifies this execution. The value of this column is obtainable by calling the getID method of the job execution object. Version, job instance ID, foreign key from the batch job instance. Table, it indicates the instance to which the execution belongs. There may be more than one execution per instance. Create time, timestamp representing the time when the execution was created. Start time, timestamp representing the time when the execution was started. End time, timestamp representing the time when the execution finished, regardless of success or failure. An empty value in this column when the job is not currently running indicates that there has been some type of error and framework was unable to perform the last save before failing. Status, character string representing the status of the execution. This may be completed, started, and others. Object representing of this column is batch status enumeration. Exit code, character string representing an the exit code of the execution. In this case, in the case of a command line job, this may be converted into a number. Exit message, character string representing a more detailed description of how the job exited. In the case of failure, this might include as much of the stack trace as is possible. Last updated, timestamp representing the last time this execution was persisted. Batch step execution table. Batch step execution table holds all the information relevant to the step execution object. This table is similar in many ways to the batch job execution table, and there is always at least one entry per step for each job execution created. The following list describes each column. Step execution ID, primary key that uniquely identifies this execution. The value of this column should be obtainable by calling getID method of the step execution object. Version, and then step name of the step to which this execution belongs. Job execution ID, foreign key from the batch job execution ID. table. This indicates jobs execution to which this step execution belongs. There may be only one step execution for a given job execution. There may be only one step execution for a given job execution for a given step name. Start time. Timestamp representing the time when the execution was started. End time. Timestamp representing the time when the execution was finished, regardless of success or failure. An empty value in this column, even though the job is not currently running, indicates that there has been some type of error and the framework was unable to perform a last save before failing. Status. Character string representing the status of the execution. This may be completed, started, and others. Object representing of this column is the batch status enumeration. Commit count. Number of times in which the steps has committed a transaction during this execution. Read count. Number of items read during this execution. Filter count. Number of items filtered out of this execution. Write count. Number of items written and committed during this execution. Read skip count. Number of items skipped on read during this execution. Write skip count. Number of items skipped on write during this execution. Process skip count. Number of items skipped during processing during this execution. Rollback count. Number of rollbacks during this execution. Note that this count includes each time rollbacks occurs during rollbacks for retry and those in skip recovery procedure. Exit code. Character string representing the exit code of the execution. In this case of command line job, in the case of a command line job, this may be converted into a number. Exit message. Character string representing a more detailed description of how the job exited. In the case of a failure, this might include as much of the stack trace as is possible. Last updated. Timestamp representing the last time this execution was persisted. The batch job execution context table. The batch job execution context tables holds all information relevant to the execution context of a job. There is exactly one job execution context for each job execution, and it contains all the job level data that is needed for a particular job execution. This data typically represents the state that must be retrieved after a failure so that job instance can start where it is left off. Following list describe each column. Job execution ID. Foreign key representing the job execution to which the context belongs. There may be more than one row associated with this given execution. Short context. The string version of the serialized context. Serialized context. The entire context serialized. Batch step execution context table. The batch step execution context table holds all the information relevant to the execution context. of a step, there is exactly one execution context per step execution, and it contains all the data that needs to be persisted for a particular step execution. This data typically represents the state that must be retrieved after a failure, so that the job instance can start where it left off. The following list describes each column: step execution ID, foreign key representing step execution to which the context belongs. There may be more than one row associated with the given execution. Short context, string version of the serialized context. Serialized context, the entire context serialized. Here you can see batch job instance. Batch job instance can have one or many batch job executions. Batch job execution can have one and only one batch job instance. Batch job execution can have batch job execution has one or many batch job execution params. Batch job execution params has one and only one batch job execution. Batch job execution has one or many batch job execution context. Batch job execution context has one and only one batch job execution. Batch job execution has one or many batch job step execution. Batch job step execution has one and only one batch job execution. Batch step execution has one or many batch step execution batch step execution context. Batch step execution context has one and only one batch step execution. As an example, we can consider interface job repository. Repository responsible for persistence of batch metadata entities. This is in the package org.springframework.batch.core.repository. There are still few configuration options available, as following example shows. When using @enable batch processing, a job repository is provided for you. The job repository is used for basic CRUD operations of the various persisted domain object within Spring Batch, such as job execution and step execution. It is required by many of the major framework features such as JobLauncher, Job, and Step. The batch namespace abstracts away many of the implementation details of the job repository implementations and their collaborators. However, there are still few configuration options available, as the following example shows. This is XML configuration. Other than ID, none of the configuration option listed here are required. If they are not set, defaults are used. The max varchar length default to 2500, which is the length of the long varchar columns in the sample schema scripts. Other than data source, and transaction manager, none of the configuration options listed here are required. If they are not set, the default shown default describes earlier are used. The max varchar length defaults to 2500, which is the length of the long varchar columns in the sample schema scripts. Now we are considering transaction configuration for job repository. Following example shows how to override the isolation level in Java. The string isolation level for create set the isolation level for create parameter value defaults to isolation serializable. This is in the interface. This is in the annotation interface enable batch processing, and which is in package org.spring framework batch .batch.core.configuration.annotation. If the namespace or provided factory bin is used, transactional advice is automatically created around the repository. This is to ensure that the batch metadata, including state that is necessary for restarts after a failure or is persisted correctly. Behavior of the framework is not well defined if the repository methods are not transactional. The isolation level in the create * method attributes is specified separately to ensure that when the jobs are launched, if two processes try to launch the same job at the same time, only one succeeds. The default isolation level for that method is serializable, which is quite aggressive. Read committed usually works quite well. Read uncommitted is fine if two processes are not likely to collide in this way. However, since a call to the create * method is quite short, it is unlikely that serialize causes problems as long as the database platform supports it. However, you can override these settings. Following example shows how to override isolation level in XML, and following example shows how to override the isolation level in Java. If the namespace is not used, you must also configure transactional behavior of the repository by using AOP. Job definition. Now we are considering changing the table prefix. The following example shows how to change the table prefix in Java. String table prefix, the batch table prefix default to batch. This is in the annotation interface enable batch processing, and which is in the package org.spring framework.batch.core.configuration.annotation. Another modifiable property of the job repository is the table prefix of the metadata tables. By default, they are all prefaced with batch_.batch job execution and batch step execution are two examples. However, there are potential reasons to modify this prefix. If the schema names need to be prepended to the table names, or if more than one set of metadata tables is needed within the same schema, the table prefix need to be changed. Following example shows how to change the table prefix in XML. The following example shows how to change the table prefix in Java. Job definition. Now we are considering non-standard database types in a repository. The following example shows how to use job repository factory bean to set the database type to the closest match in Java. The class job repository factory bean, a factory bean that automates the creation of a simple job repository using JDBC DAO implementations which persist batch metadata in a database, requires the user to describe what kind of database they are using. If you use a database platform that is not in the list of supported platforms, you may able to use one of the supported types if the SQL variant is close enough. To do this, you can use the raw job repository factory bean instead of the namespace shortcut that and use it to set the database type to close match. The following example shows how to use job repository factory bean to set up database type to the closest match in XML. The following example shows how to use job repository factory bean to set database type to the closest match in Java. If the database type is not specified, job repository factory bean tries to auto detect the database type from the data source. The major difference between platforms are mainly accounted for by the strategy for incrementing primary keys. So it is often necessary to override the incrementer factory as well by using one of the standard implementation from the Spring framework. Even if that does not work, or if you are not using an RDBMS, the only option may be to implement the various DAO interfaces that the simple job repository depends on and wire one up manually in the normal Spring way. As an example, we can consider class job instance already complete exception, an exception indicating that an illegal attempt to restart a job that was already completed successfully. This is in the package org.springframework.batch.co.repository. As an error example, we can considering this existing transaction detected in job repository. Please fix this and try again. For example, remove a transaction annotation from the client, etc. And yeah. Now we are focusing on ItemReader. ItemReader is an abstraction that represents the retrieval of input for a step, one item at a time. When the item reader has exhausted the items it can provide, it indicates this by returning null. Here you can see a XML input. Spring Batch provides transactional infrastructure for both reading XML records and mapping them into Java objects, as well as writing Java objects as XML records. Constraints on streaming XML. The STAX API is used for I/O, as other standard XML parsing APIs do not fit the batch processing requirements. DOM loads the whole input into memory at once and SACs control the parsing process by allowing user to provide only callbacks. We need to consider how XML input and output works in Spring Batch here. First, there are few concepts that vary from file reading and writing but are common across Spring Batch XML processing. With XML processing, instead of lines of records, field set instances that need to be tokenized, it assumed an XML resource is a collection of fragments corresponding to individual records, as shown in this image. The thread tag is defined as the root element in the scenario here. Everything between thread and /thread is considered one fragment to objects. Consider one fragment. The Spring Batch uses object XML mapping OXM to bind fragments to objects. Here you can see fragment 1, and here you can see fragment 2, and here you can see fragment 3. Here we can consider OXM binding. Spring Batch uses object XML mapping OXM to bind fragments to objects. However, Spring Batch is not tied to any particular XML binding technology. Typical use is to delegate to Spring OXM, which provide uniform abstraction for most popular OXM technologies. The dependency on Spring OXM is optional, and you can choose to implement Spring Batch specific interfaces if desired. The relationship to the technologies that OXM support is shown in this diagram. Here you can see fragments. Fragments are connected to Spring OXM. Here any binding framework supported by Spring OXM, and inside Spring OXM you can see JAX B2, Caster, and XML beans. Here we are considering a cursor example related to cursor-based ItemReader implementations. Using a database cursor is generally the default approach of most batch developers, because it is the database's solution to the problem of streaming relational data. The Java result set class is essentially an object-oriented mechanism for manipulating a cursor. A result set maintains a cursor to the current row of the data. Calling next on a result set moves this cursor to the next row. In Spring Batch, cursor-based item reader implementation opens a cursor on initialization and moves the cursor forward one row for every call to read, returning a mapped object that can be used for processing. The close method is then called to ensure all resources are freed up. Spring Core JDBC template gets around this problem by using the callback patterns to completely map the all rows in the result set and close before returning control back to the method caller. However, in batch, this must wait until the step is complete. Following image shows a generic diagram of how cursor-based item reader works. Note that while the example uses XML, because XML is so widely unknown, any technology could implement the basic approach. In this example illustrates the basic pattern. Given a foo table which has 3 columns, ID, name and bar, select all rows with an ID greater than 1 but less than 7. This puts the beginning of the cursor row 1 on ID 2. The result of this row should be completely mapped foo object. Calling read again moves the cursor to the next row, which is the foo with an ID of 3. The result of this these reads are written out after each read, allowing the objects to be garbage collected, assuming no instance variables are maintaining reference to them. Here you can see the SQL statement here. Here you can see the table with ID, name and bar. As an example, we can consider interface ItemReader T strategy interface for providing the data. This is in the package org.springframework.batch.item. Although a simple concept, an ItemReader is the means for providing data from many different types of input. The most general examples include flat file. Flat file item readers read lines of data from a flat file that typically describe records with fields of data defined by fixed positions in the file or delimited by some special character such as a comma. And XML item readers process XML independently of technologies used for parsing, mapping and validating objects. Input data allows for the validation of an XML file against an XSD schema. Databases. A database source is access to return result sets which can be mapped to object for processing. The default SQL item reader implementation invoke a row mapper to return objects, keep track of the current row if restart is required, store basic statistics and provide some transaction enhancements that are enhancements. ItemReader is a basic interface for generic input operations. The read method defines the most essential contract of the ItemReader. Calling it returns one item or null if no more items are left. An item might represent a line in a file, a row in a database, or an element in an XML file. It is generally expected that these are mapped to a usable domain object such as trade, foo, or others, but there is no requirement in the contract to do so. It is expected that implementation of the ItemReader interface are forward only. However, if the underlying resource is transactional, such as JMS queue, then calling read may return the same logical item on subsequent call in a rollback scenario. It is also worth noting that a lack of items to process by an ItemReader does not cause an exception to be thrown. For example, a database reader that is configured with a query that returns 0 returns null on the first invocation of read. And interface ItemReader is in the package org.springframework.batch.item, and this is the strategy interface for providing the data. As an example too, we are considering delegate pattern and registering with the step. Here the following example shows how to inject delegate as a stream in XML. Following example shows how to inject delegate in a stream. But here you can see basically we are focusing on reader here, foo reader. In example 3, we are considering simple delimited file reading example. The file can then be read by correctly constructing a flat file item reader and calling read, as shown in this example. The class flat file item reader T, restartable item reader that reads lines from input set resource line is defined by the set record separator policy. Record separate policy and mapped to the item using set line mapper. If an exception is thrown during the line mapping, it is rethrown as a flat file pass exception, adding information about the problematic line and its line number. This is in the package org.springframework.batch.item.file. Each call to read returns a new player object that from each line of the file. When end of file is reached, null is returned. This example illustrates how to read a flat file with an actual domain scenario. This particular batch job reads in football players from the following file. Delimited line tokenizer default to comma as its delimiter. Content of this that file are mapped to the following player domain object. Setters and getters. To map field set into player object, a field set mapper that returns players that returns players need to be defined as shown in this following example. Here we are considering stacks event item reader in XML item readers. The following example shows how to define stack event item reader that works with the root element name trade, a resource of here and an unmarshaller called trade unmarshaller in Java. The class stack event item reader T item reader for reading XML input based on stack STAX. It extracts fragments from input XML document which correspond to records for processing. The fragments are wrapped with start document and end document events so that the fragments can be further processed like standalone XML documents. The implementation is not thread safe. This is in the package org.springframework.batch.item.xml. The stacks event item reader configuration provides the typical setup for the processing of records from an XML input stream. First, consider the following set of XML records that the stacks event item reader can process. To be able to process XML records, the following is needed. The root element name, the name of the root element of the fragment that constitutes the object to be mapped. The example configuration demonstrate this with the value of thread. The following example shows how to define the stack event item reader that works with root elements name thread, a resource of the XML XML, and unmarshaller is called trade marshaller. Following example shows how to define a stack event reader that works with the root element name trade resource of the XML and an unmarshaller called trade marshaller in Java. Note that in this example we have chosen to use extreme marshaller which accept an note that in this example we have chosen to use extreme marshaller which accepts an alias passed as a map with the first key and value being name of the fragment, that is root element, and the object type to bind. Then the similar to field set, the names of the other elements that map to fields within the object type as describe key and value pairs in the map. In the configuration file, we can use Spring configuration utility to describe required alias. The following example shows how to describe alias in XML. The following example shows how to describe alias in Java. On input, the reader reads XML resource until it recognizes that the new fragment is about to start. By default, the reader matches the element name to recognize that the new fragment is about to start. Reader creates a standalone document from the fragment and passes the document to deserializer, typically a wrap around a Spring OXM unmarshaller to map the XML to a Java object. To summary, this procedure is analogous to the following Java code, which uses the injection provided by the Spring configuration. Now we are considering JSON item reader. In JSON item readers, the following example shows how to define JSON item reader that works with the previous JSON resource. Org Spring Framework batch item JSON thread.json and JSON object reader based on Jackson. The class JSON item reader T item stream reader implementation that reads JSON objects from a resource having the following format. Here JSON object and JSON object. And this is in the package org.springframework.batch.item.json. Spring Batch provides support for reading and writing JSON resources in the following format. Here. It is assumed that the JSON resource is an array of JSON objects corresponding to individual items. Spring Batch is not tied to any particular JSON library. The JSON item reader delegates JSON parsing and binding to implementation of the org.springframework.batch.item.json object reader interface. This interface is intended to be implemented by using streaming API to read JSON objects in chunks. Two implementations are currently provided. Jackson through the org.springframework.batch.item.json.jackson JSON object reader, and other one is JSON through org.springframework.batch.item.json.json JSON object reader. To be able to process JSON records, following is needed: a resource, a Spring resource that represents the JSON file to read, JSON object reader, a JSON object reader to pass and bind the JSON objects to items. Following example shows how to define JSON item reader that works with the previous JSON resource. org/springframework/batch/item/JSON/thread.json and JSON object reader based on Jackson. Now we are considering multi-file input. Following example shows how to read files with wildcards in Java. The class multi-resource item reader T reads items from multiple resource sequentially. Resource list is given by set resources resource array. Here you can see with the builder. An actual reading is delegated to set delegate resource aware item reader item stream. With the builder you can see it here. Input resources are ordered using set comparator to make sure resources ordering is perceived between job runs in restart scenario. This is in the package org.springframework.batch.item.file. It is common requirement to process multiple files within a single step. Assuming that assuming the files all have the same formatting, multi-resourced item reader supports this type of input for both XML and flat file processing. Consider the following files in a directory. File 1.txt, file 2.txt, and ignored.txt. File 1.txt and file 2.txt are formatted the same, and for business reasons should be processed together. The multi-resource item reader can be used to read in both files using wildcards. Following example shows how to read files with wildcards in XML. Following example shows how to read files with wildcards in Java. In reference delegate is a simple flat file item reader. The above configuration reads input from both files, handling rollback and restart scenarios. It should be noted that, as with any item reader, adding extra input, in this case a file, could cause potential issues when restarting. It is recommended that batch jobs work with their own individual directories until completed successfully. Input resources are ordered by using multi-resource item reader set comparator to make sure resource ordering is preserved between job runs in restart scenario. Now we are considering cursor based item reader. implementations in database. JDBC cursor item reader. The following here the following example shows how to inject an item reader into steps in Java. The class JDBC cursor item reader T, simple item reader implementation that opens a JDBC cursor and continually retrieves the next row in the result set. This is in the package org.springframework.batch.item.database. The following example shows how to inject an item reader into a step in XML. JDBC cursor item reader is the JDBC implementation of the cursor-based technique. It works directly with the result set and requires an SQL statement to run against connection obtained from a data source. The following database schema is used as an example here. Many people prefer to use a domain object for each row. So the following example uses an implementation of the row mapper interface to map customer credit. Because the JDBC cursor item reader shares key interfaces with JDBC template, it is useful to see an example of how to read in this data with JDBC template. It is useful to see an example of how to read this data with JDBC template. In order to contrast it with the item reader, for the purposes of this example, assume there are 1000 rows in the customer database. The first example uses JDBC template here. So, for simplicity, we check and assume data source is already obtained. After running the preceding code snippet, the customer credit list contains 1000 customer credit objects. In the query method, a connection is obtained from the data source. The provided SQL is run against it, and the map_row method is called for each row in the result set. Contrast this with the simplicity check. Assume data source has already been obtained. Contrast this with with the approach of the JDBC cursor ItemReader shown in the following example. After running the preceding code snippet, here the counter equals 1000. If the code above had put the returned customer credit into a list, the result would have been exactly same as the JDBC template example. However, the big advantage of the ItemReader is that it allows items to be streamed. The read method can be called once, item can be written out by an ItemWriter, and then the next item can be obtained with read. This allows item reading and writing to be done in chunks and committed periodically, which is essential of high performance batch processing. Furthermore, it is easily configured for injection into a string batch step. The following example shows how to inject an ItemReader into a step in Java. Now we are considering reusing existing services. The following Java example uses ItemReader adapter. The class ItemReader adapter T invokes a custom method on a delegate plain old Java object which itself provide an item. This is in the package org.springframework.batch.item.adapter. Batch systems are often used in conjunction with other application styles. The most common is an online system, but it may also support integration or even a thick client application by moving necessary bulk data that each application style uses. For this reason, it is common that many users want to reuse existing DAOs or other services within their batch jobs. The Spring container itself make this fairly easy by allowing any necessary class to be injected. However, there may be cases where the existing service need to act as an item reader or item writer, either to satisfy dependency of another Spring Batch class, so because it truly is the main item reader for the for a step. It's fairly trivial to write an adapter class for each service that need wrapping, but because of it is such a common concern, Spring Batch provide implementations, item reader adapter and item writer adapter. Both classes implement the standard Spring method by invoking delegate pattern and are fairly simple to set up. The following XML example uses item read adapter. The following Java example uses the item read adapter. One important point to note is that the contract of the target method must be same as the contract for read. When exhausted, it returns null, otherwise it returns an object. Anything else prevents the framework from knowing when processing should end, either causing an infinite loop or incorrect failure depending upon the implementation of the item writer. Now we are considering preventing state persistence. The following bean definition shows how to prevent state persistence in Java. The method public JDBC cursor item read reader builder t save state boolean save state configure if the state of the item stream support should be persisted within the execution context for restart purposes. This is in the class JDBC cursor item reader builder t and in the package org.springframework.bash.item.database.builder. By default, all of the item reader and item writer implementation store their current state in the execution context before it is committed. However, this may not always be the desired behavior. For example, many developers can choose to make their database readers rerunnable by using process indicator. An extra column is added to the input data to indicate whether or not it has been processed. When a particular record is being read or written, the process flag is flipped from false to true, SQL statement can then contain an extra statement where in the where clause such as where process ind equal false, thereby ensuring that only unprocessed records are returned in case of a restart. In this scenario, it is preferable not to store any state such as current row number, since it is irrelevant upon restart. For this reason, all readers and writers include save state property. The following bean definition shows how to prevent save state persistence in XML here. And following bean definition shows how to prevent state persistence in Java. The ItemReader configured above does not make any entries in the execution context for any executions in which it participates. Here we are considering custom item reader in creating custom item readers and item writers. We start by implementing most basic contract of item reader. The read method as shown in this following example. The interface item reader T, a strategy interface for providing the data. This is in the package org.spring framework.bash.item. For the purpose of this example, we create a simple item reader implementation that reads from a provided list. We start by implementing the most basic contract of item reader and read method as shown in the following code. This class takes a list of items and return them one at a time. Removing each item from the list. When the list is empty, it returns null, thus satisfying the most basic requirement of an item reader, as illustrated in this in the following test code here. Now we are considering decorators in ItemReader implementations. When using an ItemReader that is not thread safe, Spring Batch offers the synchronized item stream reader decorator, which can be used to make the ItemReader thread safe. The class synchronized item stream reader T. This is a simple item stream reader decorator with a synchronized item reader dot read method, which makes a non-thread safe item reader thread safe. However, it's if processing an item is problematic, then using this will make a job not restartable. This is in the package org.springframework.batch.item.support. When using an item reader that is not thread safe, Spring Batch offers the synchronized item stream reader decorator, which can be used to make the item reader thread safe. Spring Batch provide synchronized item stream reader builder to construct an instance of the synchronized item stream reader. Now we are considering the example. Put together a batch job. Now we can add the following beans here to batch configuration class define a reader here. With business data, typically your customer or a business analysis supplies a spreadsheet. For this simple example here, you can find some made up data in src main resources sample data.csv. This spreadsheet contains the first name and a last name on each row, separated by comma. This is fairly common pattern that Spring can handle without customization. And create a business class here. Now you can see the format of data inputs and outputs. You can write a code to represent raw data, as the following example from source main java.com example batch processing person.java shows here. You can instantiate a person class either with first and last name through a constructor or by setting the properties. Now add the following beans to your batch configuration class to define a reader, processor, and a writer. The first chunk of the code defines the input, processor, and output. Here the reader creates a item reader. It looks for a file called sample data.csv and passes each line item through information to turn it into a person. Now we are considering exception handler in fat files in fat file item reader in fat files as an exception example. However, if the number of column names does not match the number of columns found while tokenizing a line, if the column names does not match the number of columns found while tokenizing a line, the field set cannot be created, and incorrect token count exception is thrown, which contains the number of tokens encountered and the number of expected, as shown in the following example here. The class incorrect token count exception indicating that an incorrect number of tokens have been found while passing a file. This is in the package org.spring-framework.batch.item.file.transform. Both delimited line tokenizer and fixed length line tokenizer have ability to specify column names that can be used for creating a field set. However, if the number of column names does not match the number of columns found while tokenizing the line, the field set cannot be created, and incorrect token count exception is thrown, which contains the number of tokens encountered and the number of expected, as shown in the following example here. Because the tokenizer was configured with 4 column names, but only 3 tokens were found in the file, an incorrect token count exception was thrown. And as an example, exception example 2, we can consider ItemReader exception. Class ItemReader exception, a base class exception class that all exceptions thrown from an ItemReader extent. This is in the package org.spring-framework.batch.item. As an error example, we can consider this. Encountered an error executing stepped randoms in job ETL loads. org.spring-framework.batch.item.item stream exception failed to initialize the reader at org.spring-framework.batch.item.support.abstract item counting item stream item reader open, etc. Now we are focusing on ItemProcessor. ItemProcessor is an abstraction that represents the business processing of an item. While the ItemReader reads one item and the ItemWriter writes one item, the ItemProcessor provides an access point to transform or apply other business processing. If while processing the item, it is determined that the item is not valid, returning null indicates that the item should not be written out. As an example, we can consider interface ItemProcessor IO. Interface for item transformation. Given an item as input, this interface provides an extension point which allows for the application of business logic in an item oriented processing scenario. It should be noted that while it's possible to return a different type than the one provided, it's not strictly necessary. Furthermore, returning null indicates that the item should not be continued to be processed. This is in the package org.spring-framework.batch.item. Here, in the example 2, we are considering this. The foo processor can then be injected into step, as following example shows here. The interface ItemProcessor IO interface for item transformation. Given an item as input, this interface provides an extension point which allows for the application of business logic in an item-oriented processing scenario. It should be noted that while it's possible to return a different type than one provided, it's not strictly necessary. Furthermore, returning null indicates that the item should not be continued to be processed. This is in the package org.springframework.batch.item. An item processor is simple. Given one object, transform it and return to another. The provided object may or may not be of the same type. The point is that business logic may be applied within the process, and it is completely up to the developer to create the logic, create that logic. An item processor can be wired directly into a step. For example, assume an item reader provides the class type foo, and that need to be converted to type bar before being written out. The following example shows an item processor that performs the conversion. In this example, there is a class named foo, a class named bar, and a class named foo processor that adheres to the item processor interface. The transformation is simple, but any type of transformation could be done. The bar writer writes bar object, throwing an exception if any other type is provided. Similarly, the foo processor throws an exception if anything but foo is provided. The foo processor can be perform simple transformation, convert foo to a bar. Write bars. The foo processor can then be injected into step, as following example shows in XML configuration here. In Java configuration here. The difference between item processor, item reader, and item writer is that item processor is optional for a step. Uh, um, Now we are considering chaining item processors. Just as with previous example, you can configure the composite processor into a step. The class composite item processor IO composite item processor that passes the item through a sequence of injected item transformers. Return value of the previous transformation is the entry value for the next. This is in the package org.springframework.batch.item.support. Performing a single transformation is useful in many scenarios, but what if you want to chain together multiple item processor implementations? You can do so by using composite pattern mentioned previously to update the previous single transformation example. Foo is transformed to bar, and which is transformed to foo bar. And written out as following example shows. Perform simple transformation, convert foo to a bar. Write items. A foo processor and a bar processor can be chained together to give the resultant foo bar. As shown in the following example. Just as with the previous example, you can configure the composite processor into step. And in Java configuration, Um, Here we are considering validating input. Spring Batch provide and validating item processor as the following bean definition shows. The class validating item processor T, simple implementation of item processor that validates input and returns it without modifications. Should the given validator throw an validation exception, this processor will rethrow it to indicate the item should be skipped unless set filter boolean is set to true, in which case null will be returned to indicate the item should be filtered. This is in the package org.spring framework.batch.item.validator. Each major implementation throws an exception if it is not well formed. The fixed length tokenizer throws an exception if a range of data is missing. Similarly, the attempting to access an index in a row mapper or field set mapper that does not exist or is in a different format than one expected causes an exception to be thrown. All of these types of exception are thrown before read returns. However, they do not address the issue of whether or not the returned item is valid. For example, if one of the fields is an age, it cannot be negative. It may pass correctly because it exists and is a number, but it does not cause an exception. Since there are already a plethora of validation frameworks, Spring Batch does not attempt to provide yet another. Rather, it provides a simple interface called validator. That you can implement by any number of frameworks. The contract is that validate method throws an exception if the object is invalid and returns normal if it is valid. Spring Batch provides an validating item processor as following being definition shows. And here the Java configuration. You can also use bean validating item processor. In our example, create an intermediate processor. Now add the following beans to your batch configuration class to define processor, and read ItemReader and ItemWriter. Create an intermediate processor. The common paradigm in batch processing is to ingest data, transform it, and then pipe it out to out somewhere else. Here you need to write a simple transformer that converts names to uppercase. Following listing from source main Java com example batch processing person ItemProcessor.java shows how to do so. The person ItemProcessor implements Spring Batch ItemProcessor interface. This make it easy to write code into a batch job that according to the interface you received an incoming person object, after which you transform it to an uppercase person. Now here add the following beans to your batch configuration class to define reader, processor, and writer. The first chunk of the code define input, processor, and output. The processor creates an instance of person ItemProcessor that you defined here, meant to convert data to uppercase. As an Exception example, we can consider exception thrown if exception occurs during processing in method at nullable or process at non-null item interface which is in the interface ItemProcessor IO of in the package Spring framework.bash.item. As an error example, we can consider this processor Spring framework.bash.item.itemProcessor question mark super java.lang.object question mark in simple step builder cannot be applied to com.ss.task.business.download.process.movie processor. Now we are focusing on ItemWriter. ItemWriter is an abstraction that represents the output of a step, one batch or chunk of items at a time. Generally, an ItemWriter has no knowledge of the input it should receive next and knows only the item that was passed in its current invocation. Here you can see error on flush. While both we are considering here database item writers, while both flat files and XML files have a specific item writer instance, there is no exact equivalent in the database world. This is because transaction provides all the needed functionality. ItemWriter implementations are necessary for files because they must act as if they are transactional, keeping track of written items and flushing or cleaning at the appropriate times. Databases have no need for this functionality since the write is already contained in a transaction. Users can create their own DAOs that implement the ItemWriter interface or use one from custom item writers that's written for generic processing concerns. Either way, they should work without any issues. One thing to look out for is the performance and error handling capabilities that are provided by batch output, by batching the output. This is the most common when using Hibernate as an item writer, but could have the same issues when using JDBC batch mode. Batching database outputs does not have any inherent flaws. Assuming we are careful to flush and there is no errors in data. However, any errors while writing can cause confusion because there is no way to know which individual item caused an exception or even if any individual item was responsible as illustrated here. If the items are buffered before written, any errors are not thrown until buffer is flushed just before commit. For example, assume that 20 items are written per chunk and the 15th item throws a data integrity violation exception. So far as the step is concerned, all 20 items are written successfully since no way to know that an error occurs until they are actually written. Once session flush is called, the buffer is emptied and the exception is hit. At this point there is nothing the step can do. The transaction must be rolled back. Normally this exception might cause item to be skipped depending on the skip retry policies, and then it is not written again. However, it is in the batch scenario, there is no way to know which item caused the issue. The whole buffer was being written when the failure happened. The only way here you can see step, ItemWriter, session and transaction manager. Execution is passed to step, and begin is passed from step to transaction manager. Then write item is passed from step to ItemWriter. Update is passed from ItemWriter to session. Update is passed from ItemWriter to session. Flush is passed from ItemWriter to session. And here the error. A rollback is passed from step to a transaction manager. Here we are considering error on write. One way to resolve an issue with errors is to flush after each item. This is a common use case, especially when using Hibernate, and the simple guideline for implementation of ItemWriter is to flush each call to write. Doing so allows the item to be skipped reliably, with Spring Batch internally taking care of the granularity of the calls to ItemWriter after an error. Here you can see step, ItemWriter, session and transaction manager. Here you can see execute is passed to step, and begin is passed from step to transaction manager. Write item is passed from step to ItemWriter. Update is passed from ItemWriter to session, and flush is passed from ItemWriter to session. And again, write item is passed from step to ItemWriter. Update is passed from ItemWriter to session. Flush is passed from ItemWriter to session, and here's error. And rollback is passed from step to transaction manager. Now we are considering interface ItemWriter T, basic interface for generic output operations. Class implementing this interface will be responsible for serializing object as necessary. Generally, it is responsibility of implementing class to decide which technology to use for mapping and how it should be configured. This is in the package org.springframework.batch.item. ItemWriter is similar in functionality to ItemReader, but with inverse operations. Resources still need to be located, opened and closed, but they differ in that an ItemWriter writes out rather than reading in. In the case of database or queues, these operations may be inserts, updates or sends. Formats of serialization of the output is specific to each batch job. As with ItemReader, ItemWriter is fairly generic interface. As with read on ItemReader, writes provides the basic contract of ItemWriter. It attempts to write out the list of items passed in as long as it is open, because it is generally expected that items are batched together into a chunk and then output. The interface accepts a list of items rather than an item by itself. After writing out the list, any flushing that may be necessary can be performed before returning from the write method. For example, if writing to a Hibernate DAO, multiple calls to write can be made, one for each item. The writer can then call flush on the Hibernate session before returning. Here now we are considering a delegate patterns and registering with the steps. Following example shows how to inject a delegate as a stream in XML. The class composite the class composite ItemWriter T calls an collection of item writers in fixed order sequence. It is in the package org.springframework.batch.item.support. Note that the composite writer is an example of the delegation pattern, which is common in Spring Batch. The delegates themselves might implement callback interfaces such as step listener. If they do, and if they are being used in conjunction with Spring Batch core as part of step in a job, then they almost certainly need to be registered manually with the step. Reader, writer, or processor that is directly wired into the step gets registered automatically if it implements the item stream. Or step listener interface. However, because the delegates are not known to the step, they need to be injected as listeners or streams or both if appropriate. Following example shows how to inject a delegate as a stream in XML. And following example shows how to inject a delegate as a stream in Java. Here we are considering a simplified file writing example in flat file item writer in flat files. In Java, a simple example of configuration might look like following. The class flat file ItemWriter T. This class is an item writer that writes data to a file stream. The writer also provides restart. The location of the output file is defined by the resource and must represent the writable file. Now the line aggregator interface is its most basic implementation. Pass-through line aggregator have been defined. The basic flow of writing can be explained. One, the object to be written is passed to the line aggregator in order to obtain a string. Return to the return string is written to the configured file. In XML, the sample example of configuration might look like following, and in Java, a simple example of configuration might look like following. Now we are considering stack event item writer. Here it is demonstrating the programmatic setup of the required properties. The class stack event item writer T, an implementation of item writer which uses STAX and marshaller for serializing object to XML. This item writer also provide restart statistics and transaction features by implementing corresponding interfaces. And implementation is not thread safe. This is in the package org.springframework.batch.item.xml. The output work symmetrically to input. Stack event item writer needs a resource, a marshaller, and a root tag name. A Java object passed to a marshaller, typically standard Spring OXM marshaller, which writes to a resource by using custom event writer that filters the start document and end document events produced for each fragment by OXM tools. Following XML examples uses marshalling event writer serializer. And following example, Java example uses marshalling event writer serializer. The preceding configuration setups the three required properties and sets the optional overwrite output equal true. Mention whether an existing file can be overwritten. Here we are considering JSON item writers. Following example shows how to define JSON file item writer. The class JSON file item writer T item writer that writes data in JSON format to a output file. The location of the output file is defined by the writable resource and must present a writable file. Items are transformed to JSON format using JSON object marshaller. Items will be enclosed in a JSON array as follows. JSON object here and here JSON object. And the implementation is not thread safe, and this is in the package org.springframework.batch.item.json. The JSON file item writer delegates the marshalling of item to the spring.org.springframework.batch.item.json.json object marshaller interface. Contract of this interface. The contract of this interface is to take an object and marshal it to a JSON string. Two implementations are currently provided. Jackson through org.springframework.jackson.json.jackson JSON object marshaller. Other one is JSON through org.springframework.batch.item.json .json JSON object marshaller. To be able to write JSON records, the following is needed: a resource, a Spring resource that represents the JSON file to write, JSON object marshaller, a JSON object marshaller to marshal object to JSON format. Following example shows how to define the JSON file item writer. Now we are considering reusing existing services. The following Java example uses the ItemWriter adapter. Here the class ItemWriter adapter T delegates item processing to a custom method, passes the item as an argument for the delegate method. This is in the package org.springframework.batch.item.adapter. Batch systems are often used in conjunction with other application styles. Most common is an online system, but it may also support integration or even a thick client application by moving necessary bulk data that each application style uses. For this reason, it is common that many users want to reuse existing DAOs or other services in their batch jobs. Spring container itself make this fairly easy by allowing any necessary class to be injected. However, there may be cases where an existing service needs to act as an item reader or item writer, either to satisfy dependency of another Spring batch class or because it truly is the main item reader for a step. It is fairly trivial to write an adapter class for each service that need wrapping, but because it is such a common concern, Spring Batch provide implementations ItemReader adapter and ItemWriter adapter. Both classes implements the standard Spring method by invoking delegate pattern and are fairly simple to set up. Following XML example, XML example uses ItemWriter adapter, and the following example uses following Java example uses ItemWriter adapter. Now we are considering creating custom item writers. Custom item writer example here. A list is used in order to keep the example as simple as possible here. Adding restartability is essentially the same with ItemReader, so it is not covered in this example here anyway. A list is used in order to keep the example as simple as possible here. Now we are considering ItemWriter implementations. I'm considering decorators in ItemWriter implementations. Here the synchronized item stream writer. When using a ItemWriter that is not thread safe, Spring Batch offers the synchronized item stream writer decorator, which can be used to make ItemWriter thread safe. Class synchronized item stream writer T and item stream writer decorator with the synchronized write method. This decorator is useful when using non-thread safe item writer in a multi-threaded step. Typical delegate examples are the JSON file item writer and stacks event item writer. This is in the package org.springframework.batch.item.support. When using an item writer that is not thread safe, Spring Batch offers the synchronized item stream writer decorator, which can be used to make the item writer thread safe. Spring Batch provides a synchronized item stream writer builder to construct an instance of the synchronized item stream writer. Now we are moving into our example. Put together a batch job. Now add the following beans to here your batch configuration class to define a reader, processor, and a writer. Here you can see in this example class JDBC batch item writer T, the item writer that uses batching features named from named parameter JDBC template to execute a batch statement for all items provided. This is in the package org.springframework.batch.item.database. This first chunk of code defines input, processor, and output. The writer data source creates an item writer. This one is aimed at the JDBC destination. And automatically gets a copy of the data source created by at enable batch processing. It includes SQL statement need to insert a single person given by Java bean properties. Here you can see this is the last chunk from the source main Java com example batch processing batch configuration Java shows the actual job configuration and step here. You can you can see the SQL script to create a table to store data. Here you need to write the SQL script to create a table to store data. Here Spring Boot, if you can, runs schema dash attach platform attach.sql automatically during startup. Dash all is the default for all platforms. Here the first method define a job, and the second one define a single step. In the step jobs are built from steps, where each step involved a reader, a processor and a writer. Here in a step definition, you define how much data you write at a time. In this case, it writes up to 10 records at a time. The chunk is prefixed person because it's a generic method that this represents the input and output types for each chunk of processing and lines up with the ItemReader person, ItemWriter person. As an example, we can consider ItemWriter exception, the class ItemWriter exception, a base exception class that all exception thrown from an ItemWriter extend. This is in the package org.spring-framework.batch.item. This is end of my presentation. Thank you very much for watching it.